Hello dear students, all of you welcome to Vidyan classes. Today we will discuss inverse of a matrix of order 3 using elementary operations. Elements of mathematics, exercise 4b, page number 117, question number 12b. Find the inverse of the matrix having elements 1, 2, 3, 2, 1, 4, 1, 0, 2 by elementary transformation. In elementary transform there exist two methods. Row operation, we can solve the question by row operations or column operation. First method, row operations. Let capital A be the given matrix having elements 1, 2, 3, 2, 1, 4, 1, 0, 2. Write A is equal to IA. In row operation, we write A is equal to IA. In column operations, we write A is equal to AI. Or 1, 2, 3. A is the matrix having elements 1, 2, 3, 2, 1, 4, 1, 0, 2 is equal to I the unit matrix having same order as A. So I the unit matrix having elements 1, 0, 0, 0, 1, 0, 0, 0 and 1 into A. We will transfer the given expression to the form I is equal to BA using the row operations. We will transfer A is equal to IA to the form I is equal to BA. That means A will be unit matrix I of order 3 and I will be changed to B. If the expression takes the form of I is equal to BA, then B is equal to the inverse of A. Clear? We will transfer the given expression to the form I is equal to BA. Applying first we will change the elements of column 1 as first we will change the elements of column 1 to 0, 1, 0 using row operation. First we will change the elements of column 1 as 1, 0, 1 using row operation. Applying row 2 replaced by row 2 minus 2 times of row 3 and row 3 replaced by row 3 minus row 1. In row operation, first we will change the elements of column 1 as 1, 0, 0. 2 minus 2 times of 1, that is equal to 0. So we write R2 is replaced by R2 minus 2 times of R3 and R3 is replaced by R3 minus R1, which gives, there is no change of row 1, 2 and 3. R2 will be R2 minus 2 times of R3. 2 minus 2, that is equal to 0. 1 minus 2 times of 0, that is equal to 1. 4 minus 2 times of 2, that is equal to 0. And R3 is replaced by R3 minus R1, that is 1 minus 1, that is equal to 0. 0 minus 2 minus 2. 2 minus 3, that is equal to minus 1. Clear? First, there is no change of row 1. Row 2 and row 3 elements are changes. Row 2 is replaced, row 2 minus 2 times 2 minus 2 times 1, that is equal to 0. 1 minus 2 times 0, that is equal to 1. 4 minus 2 times of 2, that is equal to 0. R3 will be, R3 is replaced by R3 minus R1. 1 minus 1, that is equal to 0. 2 minus 0 minus 2 is equal to minus 2. 2 minus 3, that is equal to minus 1. Simultaneously, the unit matrix in the right hand side changes with the same operation, by the same operation, that is R2 replaced by R2 minus 2 times of R3. R3 is replaced by R3 minus R1. There is no change of first row. Row 2 is replaced by row 2 minus 2 times of row 3, that is equal to 0. 1 minus 2 times of 0, that is equal to 1. Row 2 is replaced by row 2 minus 2 times of row 3. 0 minus 2 times of row 3, that is equal to minus 2. Row 3 replaced by row 3 minus row 1. 0 minus 1, that is equal to minus 1. 0 minus 0, that is equal to 0. 1 minus 0, that is equal to 1. Clear? Using this operation, we will change the elements of A and I into A. Clear? Next we will change the elements of column 2. Next we will change the elements of column 2. Column 2 changes to 0, 1, 0. 0, 1, 0. From this expression, we will change the elements of column 2 in the left hand side as 0, 1, 0. Clear? Applying R1 replaced by R1 plus R3. We will change the elements of column 2 as 0, 1, 0. Apply row 1, 2 plus minus 2, that is equal to 0. So we write R1 plus R3. And R3 is replaced by R3 plus 2 times of R2. It is very important. When the elements of column 2 are changes as 0, 1, 0, so that there is no change of column 1. When we change the elements of column 2, we must show that the elements of column 1 does not change. We will change the elements of column 2 so that the elements of column 1 does not change. R1 is replaced by the left hand side. R1 is replaced by R1 plus R3. The left hand side, R1 is replaced R1 plus R3, that is 1. 2 minus 2, that is equal to 0. 3 minus 1, that is equal to 2. R1 is replaced by R1 plus R3, there 1 plus 0 is equal to 1. 2 minus 2, that is 0. 3 minus 1, that is equal to 2. There is no change of row 2, 0, 1 and 0. Row 3 is replaced by row 3 plus 2 times of row 2. 0 plus 2 times of 0, that is equal to 0. Minus 2 plus 2 times of 1, that is equal to 0. 0 into 2 times of minus 1, that is minus 2. 0 plus 2 times of row 3, 0 plus 2 times of 0, that is 0, minus 2 plus 2 times of 1, that is 0, minus 1 plus 2 times of, that is equal to minus 1. Clear? Change the elements of columns 2 when the elements of column 1 does not change with the help of the given operation. The right hand side, R1 is replaced by R1 plus R3, 1 minus 1, that is equal to 0, 0 plus 0, that is equal to 0, 0 plus 1, that is equal to 1. 1 minus 1, that is equal to 0, 0 plus 0, that is 0, 0 plus 1, that is equal to 1. No change of row 2. Sorry, it is and row 3 is replaced by row 3 plus 2 times of 0, that is minus 1 plus 2 times of, that is equal to minus 1. 0 plus 2 times 1, that is equal to 2. Row 3 is replaced by row 3 plus 2 times of row 2. 1 plus 2 times of minus 2. 1 plus, that is a minus 3 into A. Clear? The first column 0, 0, 1. The second column is 0, 1, 0. Now we will change the elements of column 3. We will change the elements of column 3 as 0, 0, 1. So that the elements of column 1 and column 2 does not change. We will change the elements of column 3 as 0, 0, 1, so that there is no change of column 1 and column 2 in the left hand side. Apply. Apply. Row 1 replaced by row 1 plus 2 times of row 3. It gives 1, 2 times of row 3, that is equal to 1. 0 plus 2 times of this is equal to 0. 2 plus 2 times of row 3, that is equal to 0. There is no change of row 2 and row 3. Simultaneously, we will apply this operation on this matrix. Row 1 is replaced by row 1, 0 plus 2 times of row 3, that is equal to minus 2. 0 plus 2 times of 2, that is equal to 4. 1 plus 2 times of minus 3, that is equal to minus 5. There is no change of row 2 and row 3. 0, 1, minus 2, minus 1, 2, minus 3 into A. Clear? Now we will change the column 3, 0, 0, 1. Apply. Row 3 replaced by minus 1 into row 3. The left hand side changes to 1, 0, 0, 0, 1, 0, 0, 0, 1. And the right hand side minus 2, 4, minus 5. No change over row 1, no change over row 2, 0, 1, minus 2. Minus 1 will be multiplied with the elements of row 3, minus 1 into minus 1, that is 1, minus 2 and 3. It is the form of I is equal to BA. Therefore, inverse of A, if A is equal to IA, takes the form of I is equal to BA, B is called the inverse of A. Therefore, A inverse is equal to B, which is equal to given by, it is I, it is B, it is A, minus 2, 4, minus 5, 0, 1, minus 2, 1, minus 2 and 3. So, inverse of A, the given matrix, by row operations, it gives this result. It is the inverse of A. In method 2, we will prove the inverse of A is also this by the column operation. In method 2, we will prove the inverse of A is the same as this result by the column operation. Clear? Okay. Write down. Now we will find the inverse of the same matrix using column operations. In method 1, we have used to find the row operation. Now we will find the inverse of the same matrix using column operations. Let capital A be the given matrix having elements 1, 2, 3, 2, 1, 4, 1, 0 and 2. Put or write A is equal to AI. In row operation, we write A is equal to IA. In column operation, we write or put A is equal to AI. Or A is the matrix having elements 1, 2, 3, 2, 1, 4, 1, 0 and 2. A remains silence. I the unit matrix, same order as A. A and I have the same order. Now we will find the inverse. We will convert the left hand side as the unit matrix I and the right hand side A is equal to, and the right hand side AB. If this takes this far, then B will be the inverse of A. Using column operation, we will convert the left hand side as unit matrix, and the unit matrix in the right hand side takes the form of B, so that B will be the inverse of A. Now we will change the elements of row 1 as. Now we will change the elements of row 1 as 1, 0 and 0 using the column operations. Then we will change the elements of row 2 as 0, 1, 0 and then the elements of row 3 will be 0, 0, 1 using the column operations. First we will change the elements of row 1 as 1, 0, 0 using column operation. Apply column 2 replaced by column 2 minus 2 times of column 1. Column 3 is replaced by column 3 minus 3 times of column 1. We will change the elements of row 1 as 1, 0, 0. It is the first step. Using column operation. Using column operation. The given expression will be column 2 is changes as column 2 is replaced by column 2 minus 2 times of column 1. 2 minus 2 times 1, that is equal to, there is no change of column 1, that is 1, 2 and 1. column 2 changes. Column 2 minus 2 times of column 1, the 2 minus 2 times of 1, that is equal to 0. 1 minus 2 times of 2, that is equal to minus 3. 0 minus 2 times of 1, that is equal to minus 2. Next, column 3 replaced by column 3 minus 3 times of 3 minus 3 times of 1, that is equal to 0. 4 minus 3 times of 2, 4 minus 3 times of 2, that is equal to 4 minus 6, that is equal to minus 2. 2 minus 3 times of column 1, 2 minus 3, that is equal to minus 1. Simultaneously, the elements of a unit matrix will be changed with the operation of this and this. A into column 2 is replaced by column 2 minus 2 times of it is the column 1, C1. Column 2 is replaced by C2 minus 2 times of column 1. C3 is replaced by C3 minus 3 times of column 1. 1, 0, 0. 0 minus 2 times of 1, that is equal to minus 2. 1 minus 2 times of 0, that is equal to 1. 0 minus 2 times of 0, that is equal to 0. C3 is replaced by C3 minus 3 times of C1, that is equal to minus 3. 0 minus 3 times 0 minus 3 times of 0, that is equal to 0. 1 minus 3 times, that is equal to 1. Clear? Now the elements of row 1 are 1, 0, 0. Now we will change the elements of row 2 as 0, 1 and 0. Now we will change the elements of row 2 as 0, 1, 0. Applying we will change the elements of row 2 without changing the elements of row 1. Column 1 replaced by column 1 plus column 1 replaced by column 1 plus column 3. Column 2 0, 1. Column 2 replaced by column 2 minus 2 times of column 3 without changing the elements of row 1. We will apply the column operation without changing the elements of row 1. It is the concept. C1 is replaced by C1 plus C3. C2 is replaced by C2 minus 2 times of C3. It gives without changing the elements of column 3. Column 1 is replaced by column 1 plus column 3. 1 plus 0, that is equal to 1. 2 plus minus 2, that is equal to 0. 1 minus 1, that is equal to 0. C2 minus 2 times of C3, 0 minus 2 times of 0, that is equal to 0, minus 3 minus 2 times of minus 2, that is equal to 1, minus 2 plus 2 times of 1, that is equal to 0. Minus 2 minus 2 times of C3, it gives 0. There is no change of column 3, that is 0, minus 2, minus 1. The same operation will be applied on this matrix. A into C1 is replaced by C1 plus C3. 1 minus 3, that is equal to minus 2. 0 plus 0, that is equal to 0. 0 plus 1, that is equal to 1. C2 is replaced by C2 minus 2 times of C3, that is equal to 5 minus 2 plus 6 minus 2 times minus 2 times, that is 6, minus 2 minus 6, that is minus 4, plus 4. Minus 2 plus 6, that is equal to 4. 1 plus 2 times minus 2 times, that is equal to 1. 0 minus 2 times of 1, that is equal to minus 2. No change of column 3, that is equal to minus 3, 0 and 1. Clear? Again we apply the column operation, changing the elements of column 3, row 3, that is 0, now the elements of row 2, 0, 1 and 0, it will be 0. Apply column 3, replaced by column 3 plus 2 times of column 2. It gives 1, no change of column 1, no change of column 2. In the left hand side, column 3 is replaced by column 3 plus 2 times of column 2, that is equal to 0, minus 2 plus 2 times of column 1, that is equal to 0, minus 1 plus 2 times, it is minus 1, which is same as A. In the right hand side, minus 2, 0, 1, 4, 1 minus 2, 4, 1 minus 2. The elements of column 3, C3 minus C3 plus 2 times of column 2, minus 3 plus 8, that is equal to minus 5. 0 plus 2 times of 1, that is equal to 2. 1 plus 2 times of this minus 4 plus 1 minus 3. Now the elements of row 3, 0, 0, minus 1. We will change 0, 0, 1 using column operation. Apply C3 replaced by minus 1 into C3. C3 replaced by minus 1 into C3. It gives 1. No change of first column. No change of second column in left hand side. Third column changes minus 1 into C3. C3 is replaced by minus 1 into C3, that is 0, 0, 1. Now we will operate the same operation on this matrix. It gives minus 2, 0, 1, 4, 1, minus 2. Column 3 is replaced by minus 1, column 3, that is minus 5, minus 2 and 3. Is the form of I is equal to A into B. When A is equal to AI takes the form of I is equal to AB, then B is called the inverse of A. Therefore, B is equal to A inverse, which is equal to B means AB. Minus 2, 4, minus 5, 0, 1, minus 2, 1, minus 2, 3. It is the inverse of the given matrix using column operation. We can find out the inverse of a square matrix using column operation or row operation. In method 1, we apply the row operation. In method 2, we apply the column operation, which gives the same result. Are you clear? Okay, note down. Elements of mathematics, exercise 4b, page number 117, question number 12, fourth bit. Find the inverse of the matrix by elementary transformations. To find the inverse of the matrix, we can find out the inverse of the matrix using row operations or column operations. Suppose we apply the row operation to find the inverse. Row operations. Let capital A be the given matrix having elements 1, 1, 2, 0, 1, 2, 1, 2 and 1. For a row operation, we put A is equal to IA. For a column operation, we put A is equal to AI. For row operation, A is equal to IA. Or A having elements 1, 1, 2, 0, 1, 2, 1, 2, 1. I the unit matrix, same order as A. So I contains 1, 0, 0, 0, 1, 0 and 0, 0, 1. Order of A is same as order of I into A. First we will change the elements of column 1 as 1 0 0 using row operation. Using row operation, we will change the elements of column 1 as 1 0 and 0. Apply. Row 3 replaced by row 3 minus row 1. It gives 1 1 2. No change of row 1, no change of row 2. One minus 1. Row 3 is replaced by row 3 minus row 1. 1 minus 1, that is equal to 0. 2 minus 1, that is equal to 1. 1 minus 2, that is minus 1. The elements of column 1 are 1 0 0 using row operation, which is same as. We will apply the same operation on the unit matrix. 1 0 0 0 1 0 0. Row 3 minus row 1. 0 minus 1 minus 1. 0 minus 0, that is 0. 1 minus 0, that is equal to 1 into A. Clear? Next we will change the elements of column 2 as 0 1 0. Applying. Row 1 replaced by row 1 minus row 2. And row 3 replaced by row 3 replaced by row 3 minus row 2. Applying. Row 1 replaced by row 1 minus row 2. Row 3 is replaced by row 3 minus row 2. It gives we will change the elements of column 2 using this operation, so that there is no change of column 1. In column 1, there is no change of 1 0 and 0. Apply these operations. We will change the elements of column 2 as 0 1 0, so that there is no change of column 1. R1 is replaced by R1 minus R2. 1 minus 0, that is equal to 1. 1 minus 1, that is equal to 0. 2 minus 2, that is equal to 0. 0. Row 3, there is no change of row 2. 0, 1 and 2. Row 3 is replaced by row 3 minus row 2. 0 minus 0, that is equal to 0. 1 minus 1, that is equal to 0. Minus 1 minus 2, that is equal to minus 3, which is same as. We will apply the same operation on this matrix. R1 is replaced by R1 minus R2. 1 minus 0, that is equal to 1. 0 minus 1, that is equal to minus 1. 0 minus 0, that is equal to 0. No change of row 2. Row 3 is replaced by row 3 minus row 2. Row 3 is replaced by row 3 minus row 2. Minus 1, 0, that is equal to minus 1. 0 minus 1, that is equal to minus 1. 1 minus 0, that is equal to 1 into A. Next, we will change the elements of column 3 as 0, 0, 1 using the row operation without changing the elements of column 1 and column 2. Apply row 3 is replaced by minus 1 by 3 row 3. It gives no change of row 1, that is 1, 0, 0. No change of row 2, that is 0, 1, 2. Row 3 is replaced by minus 1 by 3, 0. It is 0, it is 0, it is 1. Which is same as no change of row 1. Under this operation, no change of row 2. Row 3 is replaced by minus 1 by 3 row 3, that is 1 by 3, 1 by 3 and minus 1 by 3 into A. Now we will change the element 2 as a 0. Applying row 2 is replaced by row 2 minus 2 times of row 3, so that it will be 0. We will change the element of column 3 using row operation, so that there is no change of column 1 and column 2. We will change the elements as the elements of column 3 as 0, 0, 1 without changing the elements of column 1 and column 2. Applying row 2 is replaced by row 2 minus 2 times of row 3. It gives no change of row 1. Row 2 is replaced, row 2 minus 2 times of row 3. 0 minus 0, that is equal to 0. 1 minus 2 times of row 3, that is equal to 1. 2 minus 2 times of 1, that is equal to 0. No change of row 3. No change of row 1. 1 minus 1, 0. Row 2 is replaced by row 2 minus 2 times of row 3. 0 minus 2 times of row 3, that is equal to minus 2 by 3. 1 minus 2 by 3, that is equal to 1 minus 2 by 3, that is 1 minus 2 by 3, that is equal to 1 minus 2 by 3, 1 by 3. 0 minus 2 times 2 by 3, that is equal to 2 by 3. And no change of row 3. 1 by 3, 1 by 3 minus 1 by 3 into A. It is the form of I is equal to BA. It is the form of of I is equal to BA. If A is equal to IA changes to the form I is equal to BA, then B is equal to the inverse of A. Therefore, B is equal to inverse of A. B is given by 1 minus 1 and 0. Minus 2 by 3, 1 by 3, 2 by 3, 1 by 3, 1 by 3 and minus 1 by 3 into A. Therefore, the inverse of the given matrix having elements 1 minus 1, 0, minus 2 by 3, 1 by 3, 2 by 3, 1 by 3, 1 by 3, minus 1 by 3. Using row operation, we get the inverse of the given matrix. Sorry, it is the only this. So B is equal to A inverse. Clear? Okay. Note down. Next, question number 12. Second bit. Find the inverse of the matrix by eliminated transformations. Suppose we will find the inverse of the given matrix by column operation. Column operation or transformation. Let capital A be the given matrix having elements 0, 1, 2, 1, 2, 3, 3, 1, 1. For column operation, we write or put A is equal to AI, where I and A have the same order, or which is same as 0, 1, 2, 1, 2, 3, 3, 1, 1 into is equal to A into I. I the unit matrix having same order as A. First we will change the elements of row 1 using column operation. First we will change the elements of row 1 as 1, 0, 0 using column operation. Applying C1 is replaced by C2 and C2 is replaced by column 1 and column 2 are interchanged. So we have 1, 2, 1, 2, 1, 0, 1, 3, 0, 1, 3. No change of column 3, 2, 3, 1. Interchanging column 1 and column 3 in the unit matrix of right hand side, it gives 0 1 0 0 1 0 1 0 0 0 0 1. Clear? Interchanging column 1 and column 2. First we will find the elements of row 1 as 1 0 and 1 using column operation. Applying C3 replaced by C3 minus 2 times of C1, so that it will be 0. It gives no change of column 1 1 2 1, no change of column 2 0 1 3, C3 minus 2 times of C1, it will be 0, 3 minus 2 times of 2, that is equal to minus 1, 3 minus 4, 1 minus 2 times of 1, that is equal to minus 1. Clear? In the right hand side, capital A, no change of column 1 0 1 0, no change of column 2 1 0 0, column 3 is replaced by column 3 minus 2 times of column 1, 0 minus 2 times of 0, that is 0, 0 minus 2 times of 1, that is minus 2, 1 minus 2 times of 0, that is equal to 0. Clear? Okay. Next, we will change the elements of row 2 as 0 1 0 using column operation. Applying column 1 replaced by column 1 plus 2 times of column 3. Column 1 is replaced by column 1 plus 2 times of column 3, and column 3 replaced by column 3 plus column 2. We will change the elements of row 2 as 0 1 0 without changing the elements of row 1, that is 1 0 0. It gives column 1 is replaced by 1 plus 2 times of column 3, that is 1, 2 plus 2 times of minus 1, that is equal to 0, 1 plus 2 times of minus 1, that is equal to 1 minus 2, that is equal to minus 1. Column 1 plus 2 times of column 3. No change of column 2 0 1 3. Column 3 is replaced by column 3 plus column 2, 0 plus 0, that is 0, 1 minus 1 0, 3 minus 1, that is equal to 2. Three minus 1, that is equal to 2, 0 and 0. In the right hand side, A into column 1 is replaced by column 1 plus 2 times of column 3, 0 plus 2 times of 0, that is equal to 0, 1 minus 4, that is minus 3, 0, 0, 0, 1. Column 3 is replaced by column 3 is replaced by 0, 1. Column 3 is replaced by C3 minus 2 times of C1. It is 1. It is C3 minus 2 times of C3 is replaced by C3 minus 2 times of C1. 0, no change of position. 0 minus 2, 0 minus 2 times of 1 minus 2 times C1. It is 1. Column 1 is replaced by 0 plus 2 times of 0, 1 plus 2 times of minus 2, that is minus 3, 0, 2 times of 1, that is equal to 2. No change of column 2, 1, 0, 0. Column 3 is replaced by column 3 plus column 2. Column 3 is replaced by column 3 plus column 2, 1 plus 0, that is equal to 1, 0 minus 2, that is equal to minus 2, 1 plus 0, that is equal to 1. Clear? Again applying. Now we will change the elements of row 3 as 0, 0, 1 without changing the elements of row 1 and row 2. Applying column operation. C3 is replaced by 1 by 2, 1 by 2 C3. It gives C3, no change of column 1, 1, 0, minus 1, no change of column 2, 0, 1, 3. Column 3 is replaced by 1 by 2, column 3, that is equal to 0, 0, 1. In the right hand side, A into no change of column 3, no change column 1, 0, minus 3, 2, no change of column 2, 1 by 2, 1 by 2, minus 1 and a half. Column 3 is replaced by 1 by 2 column 3. Again applying row 3 will be 0, 0, 1. C1 is replaced by C1 plus C3 and C1 is replaced by C1 plus C3, C2 is replaced by C2 minus 3 times of C3. 3 minus 3 times of C2 is replaced by C2 minus 3 times of C3. The given equation will be column 1 is replaced by column 1 plus column 3. 1 plus 0, that is equal to 1. 0 plus 0, that is equal to 0. Minus 1 plus 1, that is equal to 0. Column 2 is replaced by 0 minus 0, that is equal to 0. 1 minus 3 times of 0, that is equal to 1. 3 minus 3 times of it is equal also 0. 0, 0, 1. Clear? Column 2 is replaced by column 2 minus 3 times of column 3. The same operation will be applied on this matrix. C1 is replaced by C1 plus C3. 0 plus half, that is equal to half. Minus 3 minus 1, that is minus 4. 2 plus half, that is equal to 5 by 2. C2 is replaced by C2 minus C2 is replaced by C2 minus 3 times of C3. 1 3 times of 3 by 2, that is equal to half, minus 3 by 2, that is equal to minus half. 1 minus 3 by 2. 0 minus 3 times of minus minus plus, that is equal to 3. 0 minus 3 times of minus 3 by 2. Column 2 is replaced by column 2 minus 3 times of column 3. Next, there is no change of column 3. Half, minus 1 and half. Half minus 1, half. Clear? Clear? It is the form of I is equal to AB. When A equal to AI changes to I is equal to AB is the form of. Therefore, when A is equal to AI takes the form of I is equal to AB, B is equal to the inverse of A. What is the value of B? Half minus half, half minus 4, 3 minus 1, 5 by 2 minus 3 by 2 and half is the inverse of the given matrix. It is the inverse of the given matrix. Clear? Clear? Okay. Write down. Next, question number 12, first bit, find the inverse of the matrix by elementary transformations. It is a short answer type question. We can apply row transformation or column transformations. Suppose we apply the row transformations. Row transformations. Let capital A be the given matrix having elements 0, 0, 2, 0, 2, 0, 2, 0, 0. For row operation or row transformation, put A is equal to IA. Or the equation gives 0, 0, 2, 0, 2, 0, 0, 2, 0, 0 is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. The order of A is the same as order of I. Applying row 1 replaced by row 3 and row 3 is replaced by row 1. That means interchanging row 1 and row 3, the given equation will be 2, 0, 0, 0, 2, 0, 0, 0, 2. Interchanging row 1 and row 3 is the same as 0, 0, 1, 0, 1, 0. Interchanging row 1 and row 3. 0, 0, 1, 0, 1, 0, 1, 0, 0. I into A. Again applying row 1 replaced by 1 by 2, row 1, row 2 replaced by 1 by 2, row 2, and row 3 replaced by 1 by 2, row 3. The given equation will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So this same as 0, row 1 replaced by half of row 1, 0, 0, half, row 2 replaced by half of row 2, row 3 is replaced by half of row 3, half, 0, 0 into A is the form of I is equal to BA. When A is equal to IA, transform to I is equal to BA, B is equal to the inverse of A. Therefore, B is equal to A inverse, which is same as 0, 0, half, 0, half, 0, half, 0, 0. It is the inverse of the given matrix capital A. Clear? 2 or 3 marks questions. Are you clear? Okay, write down